Okay, we're back, ladies and gentlemen. We're actually going to tell you how to do calculations and stuff with Matlab. It works a lot like a pretty standard calculator with some differences. Like any calculator, there might be some idiosyncrasies to it that are a little different than others, but they're all kind of the same. So let's start with this, 2 plus 2. And we're going to talk about built-in variables. So here's one of the built-in variables, ANS, which stands for answer. It's the default variable. It's like a temporary memory. X equals that. X is permanent now. If I change, if I just type 2, for example, answer changes to 2, but X doesn't. Answer just receives whatever the output is of the previous command. It's a temporary holding place. X sets the variable. You've got to find out if things exist or not. X exists. Y does not. You don't want to overwrite things that are already in use. If you type this and you get an answer of 0, that means it's okay to use that name for the variable. EPS, that is the default, whatever type of number I'm using. We're using a double precision floating point. And it is accurate to this degree of accuracy, 10 to the negative 16th. If you're expecting 0, if you're trying to get an answer which is close to 0, but it's not, and it's something really, really tiny like this, it's a pretty good bet you have rounding errors. Now, when we're dealing with 2 digits or 3 digits, we understand rounding errors. When we're dealing with 16 digits, it's kind of hard to wrap our head around that a rounding error can be this small, but it can. Some things are not exactly 0. There's something really, really tiny like this, which means if you get a number that small, it probably means that number is actually 0 and not something really, really tiny. Remember, MATLAB acts like a calculator, like any ordinary calculator. It has so many digits of precision. MATLAB does have a symbolics processor, which works things out algebraically. And that is, there's no error in that. Mathematica is the same way. No error in any kind of symbolic process. That's like writing down the equation for the quadratic formula. What we're dealing with is numerical. We're not in the symbolic processor of MATLAB. Sometimes numerical is better. An ordinary pendulum can't be solved exactly. We have an approximation for it, which uses the sine function, but that's an approximation. This and MATLAB, but MATLAB can do it to the accuracy. It can do it numerically. It can solve the problem with this degree of accuracy numerically. Even though we don't have an exact formula for it, we can still get numbers when we plug the problem into MATLAB. That's why engineers like it a lot, because they can, we don't have to have an exact equation or an exact formula for something. We can get answers that are really, really close, really, really fast using tools like MATLAB. Finite element analysis, which is what SOLIDWORKS does. SOLIDWORKS has a lot of simulation in it, flow and heat and things like that. It's all numeric. It doesn't have exact answers. It has answers that are very close, close enough. Okay, I wanted to talk about rounding errors. It exists in MATLAB. When you see a really, really tiny number, it's probably actually supposed to be 0. Be aware of this rounding error stuff. Complex constants, I, that's the square root of -1. J, also the square root of -1. Electrical engineers, because I is a symbol used for current, electrical engineers use J for the complex constant. Here's something else MATLAB is doing. You're not supposed to have a name that starts with a digit. MATLAB has built in a special constant. This starts with 1i. There we go. It is the same. It's like 1 times I, except there's no multiplication sign in between. You cannot name your variable starting with a 1, but MathWorks does. So that if you use the complex constant, it's probably advisable to use this for the complex constant, or this. Okay, infinite. 1 divided by 0. It won't give you an error like a lot of programs would. It gives you the number infinite, not a number. Is it all lowercase? Sometimes when you mess up with upper and lowercase, notice I started with an uppercase letter and ended with a lowercase, and it was supposed to be capital N, a capital N, and or NA. Oops, it doesn't. Oh, I messed up again. NaN. Let's go for that. This or this means your result is not a number. It's text values or something like that. Something was expecting a number, but what you gave it was not a number. It was the letter A or something like that. So just be aware of that when you're working with things. It gives you a hint about what's going wrong. Here's another hint that tells you what's going wrong. The red highlight. Red highlight is a fatal error. Orange highlight is a warning. MATLAB will keep executing, but it'll give you a warning that it's not, what you're doing is not a good idea, and you probably don't want to do it in the future. So that's not a number. Pi. Might as well talk about formats right now. Pi has a lot more digits than this. So format long, and we're going to re-execute pi. This gives you a lot more digits on pi. Format short is the default of MATLAB. There we go. All right. All these extra digits are still there. You just don't see them. All these digits are still in the short format. It's just formatting. It just rounds to 4 decimal places. That's all. Like in a calculator. There's a lot more digits in the calculator that the calculation is being carried to than what you see in your calculator. Okay, another couple other format things. I'm on format compact now. The default is format loose, and let's see the difference. It's double spaced. Gives you more white space. Format loose does. I like format compact because you can see more on your screen. It's single spaced. Okay. Another thing to note, we saw this up here. MATLAB is case sensitive. I did not type lowercase NaN, and I didn't type uppercase N, lowercase a, uppercase N. I didn't do either one. And it said, I have an error. Capital A does not equal lower a. A equals 2 and a equals 3. You'll notice there's two variables over here that are created. They're not equal to each other. Matlab does have comparison operators. That's a double equal sign for equal. If you want to ask, is little a equal to uppercase A, you put a double equal sign on it. If x equals y, etc. If little a exclamation point equals, that's how, or I'm sorry, is that right? I think I'm thinking Java. This squiggle is negation, and of course equals. I remembered MATLAB. Java is exclamation point. Excel is a greater than or less than together. And MATLAB is something different altogether. It's next to the one on your keyboard, immediately to the left on your keyboard, you do the shift and do that symbol, the squiggle. It also means not. So here's not A, not equal to capital A. There, capital A. That should be a logical 0. So this is true, it's a logical 1. So not this is false. It's reading logic. It takes a little getting used to reading logic. Wait a minute. Okay. B equals so I'm making a logical variable B. Okay, when you negate B, you get you get what you expect. Now I'm trying to negate this expression. I'm probably taking not little a. This probably has to do with order of evaluation. That's kind of important. I want to not this a not equal to little a. That's true. If I negate it again, that's false. Be sure to use your parentheses. I didn't do that earlier. I will do so now. And that's probably, if something goes wrong, that's an error to look for. Okay, I'm going to go ahead and end this video here and move on to, and keep moving on for part 2.